To understand how to write ionic equations, it's important to first recognise what happens when ionic solids dissolve. So in this example, the ionic solid might be something like sodium chloride, NaCl, which of course exists as a giant ionic lattice. And when sodium chloride is dissolved, it forms NaClAq as we commonly write it, but in actual fact NaClAq can be considered Na plus ions Aq. That's like these ones here, Na plus ions surrounded by water molecules, and indeed Cl minus ions, which are separate from those Na plus ions over here and surrounded by water molecules. So in other words, the lattice dissociates when the lattice dissolves, and that's true whenever an ionic compound dissolves. And we can use this phenomenon to help to write these ionic equations. So let's begin with a worked example. So in this first example, ammonium hydroxide is reacting with sulfuric acid. So underneath, let's start off by writing the full chemical equation for this. So NH4OH for ammonium hydroxide, Aq, reacting with sulfuric acid, H2SO4, Aq, to produce ammonium sulfate, NH4 twice, SO4, Aq, and water, H2O, and an undissociated liquid. Let's start off by balancing this equation correctly. So 2 ammonium hydroxides needed on the left-hand side and 2 waters being produced on the right-hand side. Now let's separate each of these ionic substances into its constituent ions, because whenever these are dissociated in water, whenever they're dissolved in water, then they will dissociate to form those ions. So from ammonium hydroxide, we've got 2 NH4 plus ions, Aq, I'm going to put the state symbols underneath just to save a bit of space, and 2 OH minus ions, also Aq. Here we've got sulfuric acid. Sulfuric acid would also dissociate into 2 H plus ions, Aq, and SO4, 2 minus ions, Aq. Those things then react to produce on the right hand side 2 NH4 plus ions, Aq, and SO4, 2 minus ions, Aq, and the water is not dissociated, so 2 H2O or liquid. Now if you look at the left hand side and the right hand side, hopefully you can see that some of these ions are exactly the same, they are identical. So for instance, the ammonium ion here, there are 2 NH pluses and there's 2 NH4 pluses on the right hand side also. So those 2 NH4 pluses on the left and on the right are exactly the same as each other. We call those spectator ions. Similarly, the SO4 2 minus on the left and the SO4 2 minus ions on the right are also identical, so those ones are also spectator ions. So we can now simplify this down quite a bit to 2 OH minus ions on the left, 2 OH minus ions on the left, Aq, and 2 H plus ions on the left, Aq, reacting to produce 2 H2O liquids on the right hand side. Of course, by convention, we could then cancel this down further for the simplest ionic equation for this reaction, OH minus Aq plus H plus Aq reacting to form H2O liquid, just like so. Let's do a second example. Again, let's write the full equation underneath here. So Ca solid and HCl Aq reacting to form calcium chloride, CaCl2 Aq, and hydrogen H2 gas. Balance that up by putting 2 HCl's in here. So underneath, calcium solid, no dissociation to deal with there. 2 H plus ions and 2 Cl minus ions from the 2 HCl which dissociates. A Ca2 plus ion and 2 Cl minus ions from the CaCl2, which dissociates, and H2 gas, which is molecular, does not dissociate. So let's identify any spectator ions, and this time Cl- and Cl-, 2 of those on the left, 2 of those on the right. So this simplifies down to Ca solid plus 2H plus Aq reacts to form Ca2 plus Aq and H2 gas. And this helps to explain why it doesn't matter what acid we add to calcium. Calcium will always react with an acid, any old source of H plus ions, to form CO2 plus ions within the salt and releasing hydrogen gas. It doesn't matter which acid it is. One last example before you have a go at some on your own. So example 3. So this time we've got NaOH, Aq, and CuCl2, Aq, reacting to form CuOH twice, which is a solid, and NaCl, Aq. Balance that equation, we need 2 NaOHs on the left hand side, forming 2 NaCls on the right hand side, like so. So here we've got 2 Na plus, I'll put these underneath again, Aq, 2 OH minus, Aq, Cu2 plus, Aq, 2 Cl minus, Aq. Now importantly this time the CuOH twice is a solid, so does not dissociate, plus 2 Na, whoops, move that ink 1 second, a bit there, 2 Na plus Aq and 2 Cl minus Aq at the right hand side. Identify and cancel out any spectator ions, so 2 Na plus and 2 Na plus over on the right hand side, 2 Cl minuses on the left, 2 Cl minuses on the right hand side, and therefore this can simplify to 2 OH minus Aq and Cu2 plus Aq reacting to form CuOH twice solid. Okay, go and have a practice.